What is up, guys? This is John and Quinn here with an explanation of three-dimensional graphing, or more specifically, how to plot points on a three-dimensional plane. So, three-dimensional graphing is used throughout the real world, and one example of this is in air traffic control centers, where three-dimensional graphing is used to plan landing and takeoff patterns for airplanes. So, as seen here, in traditional two-dimensional graphing, you have the x-axis for horizontal and the y-axis right here for vertical. So your point, as you all know, will be the x value of 2, y value of -2, so your point is right there. Now, in 3D graphing, you have the additional axis of the z-axis here, which represents depth. So, you have the x value here of 0, the y value of 2, and the z value of 3. So you have a point of 0, 2, 3. So, three-dimensional graphing is most often used in geometry. So our example problems here, we have point A right there at 2, 4, 5. So you have your x value of 2, 1, 2. Your y value right here of 1, 2, 3, 4. They meet right there. And then you have your z value of 5. So 1, 2, 3, 4, 5. And they all meet right there. And there you have your point A. So for example 2, point B hasn't been graphed yet, but you know that point B is -1, -3, and 3. So for your x value, you have -1, probably about right there. For your y value, -3, so you say 1, 2, 3, so they'll meet right there. And finally, for your z value, you say 1, 2, 3 right there. Make that extend out, extend up. The point will most likely end up right about there. You have your point B at -1, -3, 3. Sorry, that's a little messy for you guys. Now, when you start graphing equations on a three-dimensional plane, something really interesting happens. Right here, you have the equation y equals 3 on a two-dimensional axis. So you know that y is always going to equal 3, and x can be anything. It doesn't matter what it is, but y will always stay 3. So you have a straight line parallel to the x-axis. And you would think that this is the exact same thing when you're plotting it on a three-dimensional plane. You would think that it would again be parallel to the x-axis right here. But in reality, you know that since x, doesn't matter what x is, y is always going to be 3, but you often forget about the z-axis. So z can also be anything. So what you can do, let me give you a quick sketch here, you can also make this go up or down. I need to make this line a little more straight, and that is terrible. But you can see that you can move this line anywhere up or down, and it will still, because z can also still be anything, and what you kind of end up with is you kind of end up with a plane. Instead of just a regular line, you have this flat plane for y equals 3 instead of just this one. And if you guys want to see an even better view of what this would look like on a three-dimensional plane, if I was any kind of a good artist, it would look like this. So you can clearly see that here it is, y equals 3, and you can see that it's a plane there and not just a regular line. Now what you have here is something that is far more advanced than anything that we have dove into today, but just to show you what kind of things you can create when you start graphing other things on a three-dimensional axis. The equation here is fx comma y equals cosine of x times sine of y. It's a little bit of trigonometry right there. And you get this wave effect on the axis, and it goes up like this, so you guys can see.
Hey guys, thanks for watching. I'm Quinn. I was operating the camera and doing the editing. We hope you learned something, and have a good day.